Hi, hello, vanakkam, and welcome back to yet another episode on your favorite Little Slaw YouTube channel. So today in this video, we are going to see another interesting interview question that you could have faced, which is how have you assisted the developer or the development team in fixing any performance bottleneck. So we'll see that step by step because in this video I will again have integrated another question as well that's been asked in the yesterday's uh, video, which is like he wanted to understand any performance bottleneck that arises because of the load balancing. So in this video I have integrated both. So what I'm going to do is I'm going to describe you an issue that has arisen because of load balancing. Okay, and I will take you through the steps, starting from how to find the issue and how to analyze it and how to test the issue and how to check for the issues and how to evaluate it and like starting from the optimization of it and at the end till the monitoring and fine tuning of the issue. So I'll take you through all these steps one by one, and this is going to be double the marker for you because I'm going to answer two questions because this is one interview question and you can use your load balancing as well because there are several scenarios where you must be telling the interviewer about various issues like CPU or memory. But load balancing is a quite a significant issue in the modern days when it comes to cloud. So you can very well use this as an opportunity to showcase your load balancers knowledge, right? So with no further delay, let's go to the video. And this is me, Vasan Shanmugam. I welcome you all to our Little Slaw YouTube channel. Please don't forget to subscribe to our channel if you haven't subscribed it yet. And thank you so much for all your support and likes for my video that I have shared yesterday. So please do give me the same amount of support. And please do give a thumbs up if you like this video and share the video with your friends who are preparing for their performance testing or performance engineering interview. So with no further delays, let's go to the video. And the very first step of it is how to identify the symptoms of load balancer, like imbalancing in terms of the load balancing. So we'll see that step now. So when trying to figure out if load balancing issues are causing performance problems, here are some easy steps that we can follow. And in that, the first step is identifying the symptoms of load imbalancing or any issues with the load balancer. So to find that, first thing is we have to use the monitoring tool. So we have lots of tools in the market, but out of which some of the tools which I would say are the New Relic, the Datadog, or Prometheus. So they can help you spot the problem because these tools show you how the servers are performing and it will help you to detect the issues. Like for example, if there are any high CPU or memory usage on some servers, meaning these servers were working too hard, which means the other servers are not working hard. So which significantly shows that there is a load imbalancing and there will be an increased request latency, which is like slow responses on certain servers. And also there will be an uneven traffic distribution because when some servers are overloaded while others are not used or while they are underused, there will be an uneven traffic distribution, and that's why we have to use monitoring tools to find or to identify the symptoms of the load imbalancing. And then the second step in the first one, the subsection of it, is the checking of logs. So you have to look through your server logs to see if some servers are handling a lot more traffic than the others. For example, the logs can show you the HTTP status code. Like, for example, you must have seen the 500 status code, right? The 500 server errors. So you can see HTTP status codes like 500 errors for server overload. And also you can see the response times. That's a very basic metric, the KPI, which will tell you like how long it takes to respond to a request. So by using these tools and techniques and by checking these logs, you will be able to see if some servers are getting overwhelmed while others have little to do, right? So while some servers are highly utilized and other servers are not getting utilized. So that is a sign that the load balancing is not working correctly. So that's the first part. So you have identified, now you will be able to identify, okay, so some one of the load balancers or some of the load balancers are not working fine. So at this scenario you must have a key question: are some servers overloaded or it's is that like only few servers are overloaded? And also you should check that is there an increase in error rate or is there any timeouts because of the overloaded server. So you should identify these things as well by asking this question, right? So you must ask, or you must get an idea by this time itself, like which servers are overloaded, because the moment you monitor the logs, you will be able to see the records, you will be able to see the data, right? And now we'll move on to the next step, which is analyzing the load balancing algorithm. So we saw the first step where we have to identify the issues using the monitoring and the logs. And the second step is analyzing the load balancing algorithm, because we need to check how the load balancer is set up, and also we have to find what kind of algorithm is used to distribute the traffic. So some of the common algorithms which we know are the, I mean, very common. Everybody, when you ask an interview, they will tell the very first moment they'll say round robin, right? So this one, so let me explain what round robin is. So because most of the times we say round robin, but then we do not know what exactly round robin does. So what round robin do is, so this algorithm, the round robin algorithm, sends one request to each server one by one in a loop. Okay, so in theory, every server should get an equal number of requests, but if some servers are getting overloaded, it might be because of something called a sticky sessions. So that's another keyword that you should remember. So sticky sessions, where the same server keeps getting requests from the same user, or because the requests require keeping track of certain user data, and we call it as stateful requests, or which some servers cannot handle well. Okay, so these are the scenarios. I mean, this is actually the round robin, and basically the sticky session is all about. And then the next thing is the least connections. So this algorithm, the second algorithm which I'm talking now, is the least connections. So this algorithm will send traffic to the server with the least active connections. But if the traffic is not balanced evenly, it could be because of the session persistence. What is session persistence? Whenever the same user is always sent to the same server, so this is somewhere looking closer to sticky session, but this is a little bit different in terms of the session persistence. Or there could be a long-lived connection, and that long-lived connection would be tied up to some servers more than the others. Okay, so these are some scenarios where we experience the load imbalancing, and then we do have the IP hash, because this method, the IP hash method, sends traffic based on the user's IP address, and it can lead to some servers being overloaded if a large number of users come from the same IP range, right? So, if for example, if people from Europe, in particular in one country, if they are trying to find out some response, some trying to send some request, so they will be targeted to one server and somewhere in Europe. So those servers will be overloaded, right? So that's what I'm telling about the IP hash. So three different algorithms we saw. We saw about round robin, we saw about least connections, and then we saw about IP hash. And in round robin, we talked about the sticky sessions, right? Which is same servers are getting overloaded because of the sticky session, where the same server keeps getting requests from the same user, right? And we saw about the session persistence, because the same server is always sent to the same server. So it's quite same, but it's quite different in terms of who gets the request or who sends the request, right? And now so in this step, what should you think about? So what algorithm is the load balancer is using right now? So that's a question you must need to identify. That's the entry exit criteria for you. Before you move out of this step, you should know what algorithm is used in the load balancer. And then is there any specific settings like session persistence or IP based routing is set up, because they could cause you uneven traffic. So by checking these things, you can understand if the algorithm or its configuration is causing the traffic imbalance. And now we'll move on to the third step. So in the first two steps, you have identified the issue. I mean, like you have to identify the symptoms of the issue, and then in the second one, you start to do the analysis, right? And in the third step, you have to test the load distribution across servers, because you have to simulate, or you have to emulate the scenario, the issue, right? So now we want to make sure the traffic is being spread evenly across all the servers. So to do that, we can use tools like LoadRunner, JMeter, NeoLoad, K6, Gatling, any tool, whatever tool you mentioned, you can use that any of the tool, because these tools will let you create a fake traffic, which we all know it will create some load, it will create some noise in the issue. But this will help you to see how the load balancer is handling it, because we will try several situations, like doing the even distributions. If, for example, if you can check if the traffic is being spread equally across all the servers like it should be, because every server should get equal amount of share of the users or the requests. And also the peak traffic part, where you will simulate what happens when a lot of users hit the website at once, to see if the load balancer can handle it without overloading any single server. So you're going to try two different situations here. One is the even distribution, which is the actual one that has to happen, and then the peak traffic, where you're going to use a lot of users to hit the website at the same time. Okay. So the main thing that you'll have to look at this step is how the requests are spread across all the servers, because if the load balancer works fine, it should spread the request across all the servers. And also you should check how long it takes for each server to respond, which is the latency part. Okay, and if there are any slowdowns under heavy load. So by doing this, which is doing a load distribution test across servers, you can figure out if the load balancer is working correctly in different situations, which is during the even distribution testing and during the peak traffic testing, right? So next we'll move on to the fourth step, which is checking for session stickiness, okay, which is persistence part. So now in this step, the fourth one, which where you have to check for the session stickiness or the persistence, which I would say. So we need to see if the session stickiness, or we call it as session persistence in the performance engineering jargon, whether it is turned on or not, whether it's turned on or whether it is in off mode. Because what this session stickiness does is it makes sure that whenever a user sends a request, for example, I am sending a request to Amazon.com, it always sends my user request to Amazon server A. Okay, so every time, anytime when I send it, it always goes to the same server. This is helpful for app that needs to keep track of user data, right? So now you understand why the session stickiness is used purposefully by the business, right? Because they will be able to keep track of the user data, like for example the shopping carts or the logins, because anytime when you uh, add some items in the shopping carts, they stay there, right? It's because they the server keeps track of your user data. But there's a downside as well. If certain users are sending a lot of requests, that one server could get overloaded while others stay underused. So now you understood, right? So there is one advantage for the business, that they can track the user data, they can track what is in the shopping cart. But on the downside, if certain users are sending a lot of requests, that one server could get overloaded while others get underused. So what is the solution for this? So if your app does not need users to stick to the same server every time, it's better to turn off session stickiness. And this way, the load balancer can spread requests more evenly across all servers, because I am planning to show you how to disable this in Azure load balancer. I'll show you in one of the next videos. If possible, please do watch that video as well. So you have to find for session stickiness, and you know what session stickiness is with an example, and you have to make it. You have to switch it off so that uh, the load balancer can spread the requests more evenly across all servers rather than it is sticking to one particular server. So in this stage, in this step, the fourth step where you're checking for session stickiness, you have to check, does your application really need session persistence, or could session stickiness is the reason some servers are getting too much traffic. So you have to find both these. It does not mean that uh, you have to disable it before even you find that session stickiness is the only reason for servers to get high traffic. Okay, because this will help you to figure out whether it is causing the any imbalance because of the session stickiness. Okay, so now we have completed on step 4, and now we will move on to the step 5, which is evaluating the server health and their weights. So now the step 5, where we have to evaluate the server health and weight. So what is evaluating server health and weights? We'll see it now. So some load balancers, they use a weighted system to decide how much traffic each server should handle. Okay, because servers with more power, like when I say more power, it is better CPU and more memory. So they are called as more powerful machines, or more powerful server, or the weighted systems, because they get a higher weight in terms of the CPU and its memory. So they take on more traffic. But if these weights are not set correctly, the weaker servers might get overloaded, or powerful servers might not be used enough. If this is a new information for you, I'm very glad to introduce this one, which is evaluating the server health and weights. Server health and weights, yeah. So let me give you an example. So imagine you have three servers. The server A, which is very powerful, which has a lot of CPU and a lot of memory, and then you have server B, which has a medium power. Just imagine the server B is half of what server A configuration has, and then server C is half of what the server B has. Okay. So now if the weights are set wrong, the load balancer might send too many requests to server C, which is the weakest one, which will make it to slow down, or even it will get crashed, while the server A, the most powerful one, is not doing nothing, is simply staying idle, right? So we also need to check if any servers are unhealthy or they are not performing well. Because if a server is having issues, the load balancer might accidentally keep sending traffic to it, which slows everything down, completely everything down. So you might have faced these issues, right? So in your career, you must have faced this. But you must not know why is it happening, why, or how to fix it. So this is what you have to find. Like, you have to find the server health, like which is being defined as the weighted server, or which has been defined as the weak, or which has been defined as the medium power. Because this will help you to make sure that each server has their right weight based on how powerful it is. And if a server is struggling, you have to adjust its weight, or you have to take it out of the rotation until it's fixed. So, what to do for that? So, you have to check the health of all the servers to see if they are having any health problems, and also you have to look at the weights and make sure each server is getting the right amount of traffic based on its capacity. And I'll show you how to set these weight in another video, in one of the Azure load balancer video. And we'll move on to the next step, the sixth step, where we'll see how to consider the scaling issues. So now we'll see considering the scaling issues, because not every time the problem is about how the traffic is divided, but it also can be how many servers are available to handle it, right? Because we should know that as well. Because many systems uses auto scaling, which means servers are added automatically when the traffic increases. And now in the cloud era, it's very common. Like, the moment the CPU and the memory goes above 80%, or any amount of percentage resource utilization, it automatically gets auto scaled. And that auto scaling means more servers are added automatically when the traffic increases, and it gets removed when the traffic drops, which we all know in terms of auto scaling. So if auto scaling is not working properly, the load balancer might not know about the new servers, and it could send too much traffic to the servers that are already up and running. So there is no use of auto scaling. Like, even though you have too much of servers, I mean, like, you have more amount of servers, they were not being utilized, because as I told you, they were not known to the system, right? The load balancers do not know about the new service. Okay, just for an example, let me tell you, this example is like more interesting. So imagine you have an online store that gets busy during the sales, and normally when lots of people visit the site, so new server should start up automatically, like the auto scaling part, to handle the extra traffic. But if there is a problem with how your system is set up, like for example, the load balancer might not notice the new servers, this means the old servers get overloaded because they're handling too many requests, while the new servers are not doing anything because they were not noticed, right? So that's an example which I want to tell you. And what is the solution for this? So you have to make sure the auto scaling is set up properly, or correctly, I would say, so the load balancer knows the new servers are available and they are added to the existing system. You have to use health check to automatically detect which servers are working and can take on traffic. And also you have to make sure the system can quickly add or it can remove servers based on how the traffic you have. Because just imagine your traffic utilization goes beyond 80% on of the server, and you get add new servers. But still, if the same server, the one that you're using, is again keep on getting more requests, more and more, you would still add more servers. But what is the use? There's no use. You're not adding them. You're not adding them, or you're not distributing your load, right? So that again, it in turn brings a deadlock, or it in turn sometimes it actually breaks the entire system. So what to do for this? So you have to check the auto scaling settings are right, and you have to test how long it takes for new server to start up or to spin up, and if the load balancer is routing the traffic to them. So by doing this simple step, I would say you can make sure that your system is scaling up and down correctly, and the traffic is spread evenly when new service comes online, because that's more important. You are spending too much of time for the cloud, money and time for the cloud setup, but still if you're not able to properly utilize it, then it's a waste of every effort. So now the seventh and the most important step, which is optimizing the load balancing algorithm. So far we saw about every in and out of the load balancing, but after seeing everything, you should know how to optimize the load balancers, right? Because sometimes the algorithm used by the load balancer might not be the best for your current traffic. By default, you can set up any algorithm, but you should know whether it is the right one for the current traffic. Because in this case, we can switch to a better one to improve the performance. That's what we call it as optimization. So, for example, let's say you have a load balancer using the round robin method, which sends requests one by one to each server, but some request takes longer to process. Like for example, it can be a large file upload. Okay, this causes some servers to get overloaded while others stay idle. So in this case, switching to a different algorithm, for example, like least connections, would be better, because this algorithm, the least connection algorithm, sends traffic to the server with the fewest active connections, so no single server gets overwhelmed, right? So and if you have a lot of traffic coming from certain clients, for example many users from the same location, and you're using IP hash, which routes based on IP address. So that's what IP hash is. I mean, we again have discussed this in the previous part of this video, where some servers could get too much traffic. Okay, so switching to a weighted round robin would help spread that traffic more evenly, especially if some servers are more powerful than the others. So we discussed about the weighted as well, like weighted, medium, weak. So in this scenario, you can switch from the IP hash to the weighted round robin technique, which will help you to spread the traffic more evenly, especially if some servers are more powerful than the others. So for example, for applications that need session stickiness, and you know what session stickiness is, where users stick to the same server, so you can tweak how long they can stay on the same server, right? So again, you can set up a timeout kind of settings, and tools like AWS application load balancer, or tools like Nginx, the Nginx servers, they will allow more control on this. Okay, so you do set up session stickiness, but again you do set up a timeout as well on that. Even you can see this in some ticket booking, some theater online booking. After some point of time, it gets timed out. So when you log in the next time, you will log in, you'll send your request, but that will be going to a new server rather than the old existing server, the previous server where you have did your first session existence, right? So what is the solution of this? So the first solution is switching the algorithm. So you if by understanding the business and by understanding the requests that you're getting, so you have to switch algorithms, because if the current one is not doing a good job, a great job of balancing traffic, you have to switch to a different one by analyzing the better one, the best one in terms of the distribution of traffic. And also you have to limit the session duration, or you can use a load balancer that lets you control the sticky sessions more carefully. Again, limiting the session duration is another key thing which any developer can do in terms of saving your session. In terms of security as well, because it helps you to save the user's data to go get away if he is not using for a long time. So again, limiting the session duration is helpful in terms of security and the load balancing as well. So what to do for that? So you have to test different algorithms. Yes, you have to do it with different types of traffic. You can do testing with the same load but with different algorithms, and you can understand, you can find which is the better algorithm. Okay, and then you have to monitor the traffic after you switch algorithms to see if it improves the load distribution. Okay, so you can do all these, and these are some things which, yeah, which you can tell in the interview that I did this, I did that, and because of that we do get a very good optimized load balancing algorithm, even though you do not do, but you can very well practice in your current project or in a current environment. So by doing this, you will be able to find the best way to balance the traffic, and you can avoid overloading on any of your servers. And we'll move on to the last step, the very last step. I'm not going to bore you anymore, and the very last step is monitoring and fine tuning. So you have optimized it, but still you have to it's not over. You have to again keep on monitoring, and you have to fine tune it for a better performance. So now, by doing all these 7 steps, you find out that everything is set up. And now it is important to keep an eye. That is what we call it as monitoring. So you have to keep an eye on how the traffic is being distributed to your servers, because this will help you to catch any problems early, and also it will help you to fix them before they get worse. Right? Stitching in time saves nine, right? That's an old proverb which we all know. So an example for explaining this. So imagine you have set up your load balancer, and the things seems to running smoothly after you have changed the algorithm. But over time, one server starts getting more traffic than the others, and this could cause slowdowns, right? So to avoid this, you have to use monitoring tools: Prometheus, Grafana, Datadog, AppD, tools like App Dynamics, Data. So these tools will let you watch traffic in real time and will alert you if any server is getting too much traffic. For example, if one server's load goes above 80%. So if you see an issue, you have to adjust the configurations. For weighted algorithm, you can tweak the weights to make sure powerful servers are getting more traffic and weaker servers are getting less traffic. And you can also adjust the health checks to make sure the servers are running properly, and auto scaling rules to add more servers if the traffic goes too high. So what is the solution of it? So the complete solution, or the end solution of this analysis, or the issue, the finding the bottleneck. So you have to set up alerts that notify you when the traffic is uneven or if any server is overloaded. And also you have to regularly review for any issues, and also you have to fine tune the load balancers. The load balancing, you should not leave them alone. You should keep on tuning it if you want to get a better performance. So you have to fine tune the load balancer settings to keep things running smoothly. So what to do for that? So you have to use monitoring tools to track the traffic and also to get alerts if something goes wrong. And you also have to make small adjustments every now and then to the settings over time to improve the performance and to avoid any issues. By doing this, you can quickly spot any problems, and also you can fix them before they cause slowdowns or crashes. So we have discussed a lot, I believe, in this video. So overall, a quick conclusion. So by following all these steps, all these structured approach, a performance engineer can identify and analyze and resolve the performance bottlenecks which are caused by incorrect load balancing algorithms. So the goal in this issue, or in this case scenario, is to ensure you have even traffic distribution, you have minimized latency, and also you are avoiding the overloading of individual servers while maintaining the optimal system performance. I think this is, again, thank you for watching the entire video, and thank you so much. Until I meet you in our next video, it's bye bye from us, and your favorite Little Star YouTube channel. Take care and bye bye.